So today we are talking about snapshot testing, React components with Jest. Please raise your hands if you are using React on your projects. Good. And React with Redux. Okay. And Jest. Who's using Jest? Good, good. My name is Ana Sampaio, and I'm a software engineer at Farfetch, focused on the UI development. I also co-host a Portuguese podcast called 10Web. Feel free to follow us. And I also co-host other meetups. One of them called Girls Leaning, which is with female entrepreneurs, and another one called Startup Gathering, which is about startups and entrepreneurship in general. Yeah, so today we are talking about tests. That's everywhere. So first of all, why we need tests? Well, with tests we can catch bugs before they go live. Well, some, not all. They can work as executable documentation, but only if you write explicit test cases. It makes you write testable code, which leads to write better code, and it usually results in applications that have fewer bugs, are more stable, and easier to maintain. So this is the testing pyramid. Some of you might be familiar with this. On the bottom of on the base of the pyramid, we have the unit tests that are close to the code. Then we have the integration tests that allows us to make sure that our application lives with other applications. And on the very top, we have end-to-end tests. And as we go up on the pyramid, the amount of tests should be smaller. So now, a few years ago at Farfetch, we had like an hourglass, meaning we had a lot of unit tests. We have just a few integration tests and a lot of end-to-end tests. And as you should know, end-to-end tests are very slow to run and can be very unstable if you are using live data, for example. And we had a huge problem back then in the past. And this is the pyramid we want to achieve with our React applications. So on the base of the pyramid, we have static analysis. And here we are using some tools in order to make sure that our code is correct. And we can also test the performance of our application. Then we have the unit and the integration tests. Here we use Jest and Enzyme, and we will be talking about this topic today. And on the very top of the pyramid, we have end-to-end tests with Selenium. And here we are only testing the key features of our application. And there is a proportional relation between effort and number of tests. So the more effort on test development will lead us to have less tests. And on the other hand, less effort on test development will lead us to more tests. And as we wanted to have a way to create tests easily, we decided to go for Jest. So Jest is a full-feature unit test framework, and it has all we need in terms of mocks, assertions, and it also supports snapshot testing, which is a cool feature that we'll talk about later. To set up Jest, all we need to do is install Jest, if you are using Babel, we have to install Babel Jest and tell Babel to use ES 2015 features. And then in the package.json, we can add 2 scripts, one for test and one for the test watcher. To run the tests, all we have to do is type npm test, and Jest will look for all the files that ends with .test.js or .spec.js. And Jest also comes with a great feature, which is code coverage, and it will look like this. And green means we have code coverage above the threshold, which is 80%. So today we'll be talking about what is snapshotting, what is snapshot testing and how it works. Then we'll see how we can test React and Redux components. So first of all, what is snapshot testing? Well, in general, snapshot testing is a test approach that allows to assert that the result of a given test by generating a JSON representation of its output. And what does it mean? Well, in the first time we run a test, a JSON representation of the expected output is saved into a snap file. Then, the next time you run a test, a difference between the new and the previous stored snapshot. If there are no differences, the test passes. Otherwise, the test will fail and the differences are returned. So when we run a test, Jest will check if there are snapshots available. If no, if there isn't, we save a new snapshot and the test will pass. That should be green, not yellow. Otherwise, if Jest found a snapshot, it will check if there are differences. If there aren't, the test will pass. Otherwise, the test will fail. And this is I don't know if you can see well, but this is an example of a link component. And it basically renders an anchor with a given class name, href, and text. And this is how we can test our link component with snapshot testing. Our test case is that the link should render with the required props. Then we tell Jest to render the component with a given URL and text that we mocked. We convert it into a JSON, and then we just have to expect our rendered component to match the snapshot. And this is how the snapshot looks like. And as you can see, is the rendered component. Now, let's say we already created a snapshot, and we change our mocked data. You can see, okay, this is the output after we run a test. And I don't know if you can see it well, but in green you have the previous snapshot, and in red you have the new one. In this case, we just updated the mock, so we want to keep the changes. And all you have to do is update the snapshot. So if the snapshot has changed, which was this case, we have to check if the change is expected. If you're expecting that change, we just have to update the snapshot. In this case, we just update our mock, so we can we can update the snapshot. But if we saw unexpected changes, we have to fix our code until the snapshot matches again. So snapshot testing, this is one of the main takeaways I want you to keep, is that snapshot testing allows to make sure that the UI doesn't change unexpectedly. So this solves a huge problem of the UI developers when they change something here, doesn't break or breaks something elsewhere. So if the change is intent, we can update the snapshot by typing npm test, the name of the test, and then --u. That stands for update snapshot. If not, we must fix the code until it matches the snapshot again. So how can we test React components in our React applications? Well, this is a typical way of testing. This is our link component we saw before, and we are basically rendering the component and then query the DOM in order to find the attributes you are looking for. But you can test the same thing using just one snapshot test. Here we are testing if the required props are rendered, which is exactly the same as we are testing here. But the difference is that we need 3 tests here and just one snapshot. And this is a very, very simple component. Imagine that you have a huge component with a lot of attributes to test. So I found snapshot testing very, very easier to implement when comparing to the typical approach. The typical approach is hard to implement, is hard to maintain, and there is a higher chance to leave untested parts, since we need more tests to cover everything. So we use Jest, and sometimes we use also Enzyme, and Enzyme is very helpful on DOM interactions. Enzyme allows us to render the component in 3 different ways. One of them is static rendering, which is plain HTML. Another one is shallow rendering, which is superficial rendering, and then the full DOM rendering, in case we need to wait the life cycle of the component to fully test our component. Now I have here a quick and simple demo. We are testing an expandable component, and this is the behavior of our component. So if you click here, it expands. If I click back, it collapses. So this is the code of our component, and basically we just have to apply this display none based on this props is expanded. We are applying this display none here in this style attribute. So how can we test this using snapshot testing? Well, here I started one of the tests. The test case is expandable renders with style display none when collapsed. So when our component is collapsed, we should see a display none there in order to hide the part we want. So we just have to ask Jest to render the component with some mocked props, and expect it to match the snapshot. So I'm going to run this test. There we go. So we just had one snapshot here because it was the first time we ran the test. So now we will be creating another one, which is when our expandable component is actually expanded. So I'm going to copy this test, and we want to test with, we want to make sure that our component renders with style empty when is expanded. Okay, there we go, and we have to put this through and save. Okay, so now I'm going to run this test again, and then just found two tests and both passed, and one snapshot was added. We can see the snapshot here. So it's basically inside a snapshots folder, and it looks like this. So here is our display none, and when is expanded, the style is empty. Good, it looks good now. So let's say I come back some months after this, I developed this code, and I decided to make some code refactoring, and I decided to this change and put display block here and try to do the inverse of what I was doing. So I'm going to save the file, and I'm going to run this test. Okay, so I have two tests failing, and let's see what happened. So in our test that renders with style empty when expanded, we can see here our change, which was display block. Okay, it looks good. But if we see here our first test, which is testing if the expandable renders with style none when collapsed, we can see that the display none was gone, and it was replaced with the style empty. Well, can I update the snapshots? No, I can't, because if I update snapshot, our expandable component will stop working because it won't be collapsed anymore. So I just have to change the code and undo my change because it's not working. I'm going to run the test again in order to make sure that it is passed. Okay, everything is green, and we are good to go. Okay, now it is very important when we are working with snapshot tests. It's very important to write explicit test cases. It is also important to test all the possible states of a component. And as you can see, we tested the collapsed and the expanded state of our component. And if a component is made of several components inside, we should use enzyme shallow render. And with shallow, we will render something like this. This is the parent component of our expandable component. And as you can see, we didn't render the child component. We are just rendering the parent one, which is what you want to test. This is how the render output. In this case, we are also rendering both parent and child component. It is also very important that you commit your snapshots, and we should not ignore the snapshots on code review, since we can find bugs or things that were not expected there. And we should not update snapshots blindly. We have to check the differences before update any snapshot. Okay, Jest also allows to test interactions, and this is an example of a click event. And for this, we are using simulate function of Jest. And in this case, we are clicking in the button, and we are testing if the button click is called once. But let's say that our component will change. We change something in our click. It will change something in the component. What we should do is take a snapshot before the click and after the click, so we can test both states. We can also mock functions. I don't know if you can see the code, but basically it is possible to mock the return value of a function, and this is very useful when we don't want the return value of a function to influence your tests. Imagine that we are using the date time in some calculation. Which will generate different results every time you run a function, and so the snapshot will be different every time you run the test. So mock is very useful in that cases, mocking functions. And then we have Redux components. Well, let's see how we can test action creators. Well, action creators are functions that return actions which are objects. So what we want to test here is that the right action was returned. This is an example of a to-do, of an add to-do action creator, and this is the return that that we are expecting. So how can we test this? Well, we can start mocking the text payload. We can also mock the expected action, and then we are expecting the action to return our expected action. But we can also test this with the snapshot. So instead of mocking the expected action, we can save it directly in a snapshot. So this is the result. This is how the snapshot looks like. So this is the action, and every time the action changes, you don't have to fix the test. We'll just have to update the snapshot. We can also test reducers. So a reducer should return a new state after applying action to the previous state. And in order to test a reducer, and this is a reducer called to-dos, we can start by mocking the initial state. We also have to mock the action, since these are the arguments of the reducer. We can use this deep freeze function in order to ensure the immutability of the initial state. And we just have to call the reducer with our mock data and expect it to match the snapshot. And this is the output. This is how the snapshot looks like. And this is the object of our return state. Again, every time this change, we just have to update the snapshot. We don't have to fix the test. So, snapshot testing. This is very useful to prevent unexpected UI changes. It makes code refactors very, very safer. They are very easy to implement and to maintain, and there is no more test fixes. We just have to update the snapshots. Okay, this is the resources. And thank you. That's all. Does anyone have any question?
The snapshots are stored in separate files for each test file, or they are all combined in one file? How are they organized?
You have a snapshot file for each test file. So in this case, this is the test, the component. This is the tests of the component, and as you can see, we have two tests. And this is the snapshot file, and we have the two snapshots here.
Okay. And if I have like tests nested within folders, does the folder structure will be recreated inside the snapshots folder?
I'm not sure, but I don't think that that structuring way of tests is a good way. You know?
He creates in each test folder. He creates underscore snapshot folder.
Ah.
So if you go down the folders, it will be create a new folder again.
Okay, that's nice because that way the snapshots will be near the tests.
Yes.
Which is good.
Each test folder will have a snapshot folder also.
I have a question. What about components that are mapped to the Redux store, that are connected to the store?
To the store?
Yes.
Yes. I didn't bring any example for this presentation. It's out of scope of this presentation, but it is also possible to mock the store and test your container components.
Okay.
Yes.
I've seen some examples, and I was really interested in seeing like your approach on it. That's where I struggled the most. Mm-hmm. So, but I'll have a look in it. Otherwise, you gave me some really good tips here. Thank you.
I have an example of how we can test those containers with the store with snapshot testing. I can give you later on.
Okay.
Should they be the same? You just have a snapshot with the object that connected with you?
Sorry, I didn't.
Shouldn't it be the same test? Like snapshot will be like if you have an array from Connect Redux in this case. It stores it in the snapshot.
It's sorry? Can hear you, sorry.
It will be on the snapshot.
Yes.
So you have that bit.
I do tests for our smart components, our containers with the snapshots as well.
Yeah, my question is, the data that you get from Redux will be stored on the snapshot.
Yes.
Is that way that you test with snapshots the containers?
Yes.
Okay, thank you.
So when you're updating the snapshot, is there any way for you to authenticate user? If you're a lost developer, you just update snapshot. It will be later tackled down on if you have pull request, right? And to review the code. But if you just allow the developer, you just push it. Is there any way for when you're updating a snapshot or any kind of, no, you cannot update a snapshot, only in certain users, something like that.
Protecting a single file from...
Yeah. Preventing you from yeah, you'll probably catch it later on, right? When you're doing the full review request. But if you stop it, yeah, beforehand, you know if there's any way of doing it, preventing some users from touching some files.
Actually, I'm not sure if that is possible. It should be possible, but I don't know how to achieve it.
Yeah, but maybe with a pre-commit loop.
Yeah.
Yeah, don't allow those files to be committed.
Okay. So you are saying that the snapshot files shouldn't be committed or
You should
updated?
not allow some users, some developers to update the snapshot because they shouldn't even be bothering with those files. I don't think that makes sense.
Well, in our case, we have a multidisciplinary team, and everyone do backend and frontend. We are a small team, and everyone touch the snapshots. That's the backend, so we don't have that problem.
Review, right? If you review your pull requests, you will get it because the snapshot will appear there. And if you change the snapshot, everyone in the team will notice that you changed. But yeah, I was just preventing if you could catch that earlier, I don't know, it might be interesting.
Yes. Thank you.
If you have a random function inside the process, I think perhaps before test, taking off the random function, like inserting numbers and test, and then replace with the random function. But do you have other means to test random process where random functions are integrated?
Okay, I'm not sure if I understood the question correctly, but basically you are asking what I do if I have a random function. Well, I would mock the return value to be always the same, so it won't break my tests every time I run them. Does this answer your question? Okay. Thank you.